Okay, in the previous class we have finished this one, that I n is equal to in bracket y n n minus y n r into y r r inverse into y r n bracket close, then multiplied by V n. This is equation 13. Now we will take one example, right. This example is your double circuit line, right. The problem is something like this: double circuit line. For the generator 1, that x t dash is given, right, j 0.2 per unit, and this is a double circuit line, x 1 is given j 0.40 per unit, this is also x 2 j 0.40 unit, and of course, this is another generator, but x d is not given, right. So, in this problem we have to find out pre fault, then fault, and then post fault admittance matrix, right. And fault has occurred, actually 3 phase fault has occurred in that your middle of the line, it is the middle of the line, right, that we will see later, right. So, we have to find out that your what you call that your what you call that you reduced your what you call that admittance matrix, right. So, in this case, now pre fault case. So, these are all reactances are given in per unit. So, first you convert it to admittance, that is reciprocal of it. So, x d dash will be 1 upon j 0.20. So, it is minus j 5 per unit, right. And bus number here generator 1 and generator 2 is given, but from this problem you have to create that your bus. So, this x d dash is given. So, this is that is why the generator terminal bus is marked as 1, right. And then this x d dash is given j 0.20, that means you have to take the reciprocal of this, because this will become to admittance. So, it is minus j 5 per unit. Similarly, for this one, that j 0.40 and j 0.40. So, 1 upon j 0.40. So, minus j 2.5 per unit. Similarly, here also it is written at the bottom, just hold on, right. So, in this case here also it is minus j your 0.25 per 2.5 per unit, right. And this is here no x d dash is given. So, this bus is marked as a bus 2 and this is marked as a bus 3 and this is 1, because x d dash was given. So, all these things actually are in per unit, and these are all admittance values, right. Now, when we calculate this thing, you know that when you form that your y matrix for pre fault, you have 3 bus. So, in general that y matrix for pre fault will be capital Y 11, Y 12, Y 13, right. Then Y 21, Y 22, Y 23, right, and then Y 31 capital, Y 32, then capital Y 33. This you have studied from the load flow studies. So, same thing is here, right. So, first is you find out small y 1 and small y. When we represent this one, first we will find small y, and off diagonal we will take minus of the small y, right. So, in this case, in this case, suppose when you are trying to find out all these your what you call small y values, right, y 11, then your y 13, all sort of things. If you take y 11, right, y 11, it is minus j 5 per unit for this one, right. Similarly, if you take y 13, it will be minus your what you call j 5 per unit, because no charge your what you call no charging admittances are considered here, or no load is given here, right. So, in this case what will happen, that if you look into this, that y your y 11, that is y 13, right, I told you it is small y 13 is equal to minus j 5 is equal to y 31, right. Similarly, y 32, if you take y 32 is equal to y 23 minus j 5, because this is admittance. So, minus j 2.5, this is also admittance, minus j 2.5, they are in parallel. So, it will be added because it is admittance, right. So, y 32 is equal to y 23, that is minus j 2.5 minus j 2.5. So, total is minus j 5, right. Similarly, y 11, it will be simply minus j 5, right, and y 12 is equal to no connection between 1 and 2. So, y 120 is equal to y 21, right. And similarly, your now capital Y 13 is basically minus of that small y. So, minus y 13. So, it is j 5, right. So, this you know from your load flow studies for forming bus admittance matrix, right. Similarly, capital Y21 is 0, capital Y22 will be minus j 5. Similarly, capital Y23 is equal to capital Y32 is equal to minus small y32 is equal to j 5, right, and Y31 is equal to capital Y31 will be minus small y31 is equal to j 5, and capital Y32 will be j 5, and Y33 will be minus j 5 is equal to minus j 10. It is actually minus j 10, right, minus j 5 minus j 5, right. So, if you look at in the diagram, that is Y33, that is Y33. So, Y33 will be this one, your this minus your say I am just making it is minus j 5, right, and another thing is that these two are in parallel. So, their equivalent is minus j 5. So, is equal to minus j 10 per unit, right. So, that means this is your Y33. Therefore, pre-fault bus matrix is minus j 5 0 j 5 0 minus j 5 j 5 and j 5 j 5 minus j 0, but we have two machines. So, this is your 3 bus problem. So, this is 1, this is 2, this is 3, right. We have 3 machines, but we have to reduce that Y matrix and n into n, because n is equal to here 2, because we have 2 machines, that is why this is partition, right. And this matrix we call, that is your YNN, that is why NN means this is 2, your number of machines are 2. So, we represent YNN, and this is your YNR, right, and this is YRN and this is YRR, right. This way, so we have seen this one before, right. So, now you have to reduce it into 2 into 2 matrix. So, if we follow this using this, so this is my YNN, I told you, and this is YNR and this is YRN, and YRR simply a single element, right, it is a single element. So, if we put all these things here, right, so Y dash will be your what you call, if you put and substitute, so Y dash will be minus j 2.5 j 2.5 j 2.5 minus j 2.5, right. So, this is actually this matrix generally is a symmetric matrix for 3 phase fault, right. So, because Y12 is equal to Y21, it is of course, this is a simply 2 into 2 matrix, right. So, this is your pre-fault matrix. Now, next is fault case. Now, a 3 phase fault has occurred in the middle of the line. So, if it is 3 phase fault has occurred in the middle of the line, we will go back to the diagram, right. So, fault has occurred in the middle of the line, say in the middle of the line the fault has occurred. Better we will go to the original diagram, right. So, here will come. So, fault has occurred in the middle of the line, right. If it is the middle of the line, this side it will be your this reactance will be half. So, this side it will be 0.2 and this side also it will be 0.2, right. So, when fault has occurred, when we represent it by admittance, this will be minus j 5 and this side also will be minus j 5 per unit, right. So, that means just hold on. So, that means your this diagram when fault has occurred. So, that is why this is actually your minus j 5, that is why this is minus j 5, this and the 3 phase fault has occurred, right. So, if you construct the Y matrix, it will be minus j 5 because this is minus j 5, Y11, Y12 is 0 and Y13, that is your, it is minus your of small y13. So, it will be plus j 5, this you know from your load flow studies. So, similarly, let me move little bit up. So, similarly, y21 is 0, y21 no connection between 2 and 1, y21 0 and y22 means that this one will be added, right, and fault has occurred here and then this one will be added. So, it will be minus j 5 and minus j 2.5. So, it will be minus j 7.5, right, and y your what you call 2 3 will be simply as your what you call that minus your plus j 2.5, right, because your this thing your that minus of y small minus small y 2 3, right. So, if you look into that 2 to 3, the 2 to 3, that means this is bus number 3, only this one will come because fault has occurred. So, please do not consider this one, right. This side should not be considered, only 2 to 3. So, it is minus small y 2 3. So, that is why it is plus j 2.5, right. Similarly, when you will come y 3 1, it is simply minus j 5 because plus j 5 because it is a symmetry matrix. Then y 3 2, same philosophy, y 2 3 is equal to y 3 2, it will be j 2.5, and when it will be y 3 3, then this one will be added, this one will be added, and this one will be added, right. So, in that case it will become minus 12.5 because minus j 5 and minus j 2.5. So, minus j 12.5. So, that is why this is j 5, j 2.5 and minus j 12.5, right. And this is your what you call that simply this is during fault, simply will partition, right. And this is your YNN, and this is your YNR, this is your YRN, and this is your YRR, it is single element, right. And follow the same procedure, same formula you use, and if you compute, then if you that matrix, your matrix reduction, right, reduced matrix, then final answer will be your this much, that y 2 into 2 matrix will be minus j 3 j 1 minus j 7. It is also symmetric matrix because y 1 2 is equal to y 2 1, right. So, this matrix is that is your during fault, right. This is during fault, right. So, next one is that your post fault. Post fault means that this line is when fault is clear, right. We will go back to the diagram, that when fault is cleared, right. Suppose this line it is actually removed, now it has become a single circuit line. So, in that case this one and this one will be there, but this is removed, right, during when fault is cleared. So, that means we will go back to this, I mean post fault condition. So, this is post fault. So, that line is not there. So, 1 3 and 1 2 3, and it is easily you can compute the looking at this network, you can compute that your bus admittance matrix, right, and your and again you will partition because it is a 2 into 2, right, it is a bus. So, this is your YNN, that is y 2 into 2, this is YNR, this is YRN, and this is YRR, right. And for following the same equation, you just go for matrix reduction. So, if we do so, so it will be your what we call, this will be the answer, right. So, I have not only one step or first one, the pre-fault case I showed the calculations, but this one you can easily do it, but this will be a symmetric matrix. If you do not get symmetric matrix, then somewhere might have your what we call, you might have done wrong calculations, right. Generally it is a symmetric matrix. So, we will go to another example, just hold on. So, we will take another example. So, in this case, this example that your two generators are there, but this side also all these xd dash, all these things that it has these are all given in admittance. I mean all these parameters that xd1 dash, xd2 dash and line parameters all have been converted to your admittances. So, these are all these values, this value, this value, this value and this value, they are actually admittances, right. So, this is given, and another thing is given, that your magnitude of E1, voltage E1, I mean for this bus, right, that your 1.1 per unit, and magnitude of E2 is given 1.0 per unit, right. And this is E1, this is E2, and then that pre-fault condition, if you just form that your Y matrix, right, if you form the Y matrix, so you have 4 bus 1 2 3 4 bus, right, and this voltage U1 E2, it is the generator terminal voltage behind the transient reactance, but this is we have converted to admittance, but these two are actually transient reactance, we have converted to admittance, and this voltage E1 and this voltage E2, basically this is the voltage magnitude, right, that is your behind transient reactance. So, this is your pre-fault condition Y matrix. Well, just looking at this you can easily make it, right. So, this is my pre-fault condition, that is the matrix order will be 4 into 4, because you have 4 bus system. Finally, we have to reduce it to 2 into 2, and we have to find out the power delivered pre-fault and post-fault, during fault and post-fault conditions. That is why these two voltage magnitudes are given, say, right. So, looking at this you can easily these are all admittances, right, and looking at this you can easily or what you call, you can construct the Y matrix. So, Y matrix actually it is full Y matrix, there is pre-fault condition, this is 4 into 4 matrix, right. So, easily you can make it, all small y you can calculate, small y 1 1, y 1 2, y 1 3 like this up to your y 4 1, y 4 2, y 4 3, y 4 4, small 1, then capital 1 is equal to the sum of all small 1, and off diagonal will be minus of small 1, right. So, this way you can construct the full matrix. After this we partitioned it, we have partitioned it, right, and this is your, in this case for this example, this is your YNN, and now it is YNR, it is 2 into 2 matrix, all are 2 into 2 matrix, this is YRN also 2 into 2 matrix, right, and this is your YRR, it is also 2 into 2 matrix, right. And if you look into that, these two matrices are same, J 8.33, J 28.57, this is also J 8.33 and J 28.57, right. So, using this same formula, right, that your bus reduction, same formula. So, since there are two generators in the system, the reduced matrix will be of order of 2 into 2, right. So, we know this thing, that y is equal to YNN minus YNR, then YRR inverse into YRN, this you know. So, we will substitute all, I told you that YNN, YNR, YRN, YRR, if you substitute all. So, YNN I told you, this is YNN, this is YRR, right, and this is YRN and this is YRR, right, and if this is YRR, if you invert this matrix, then it will be like this, right. So, it is a 2 into 2 matrix, you can easily invert it, you take J common and just simply you invert that one, that is all, and multiplied by J again, right. So, once you have done this, right, then y is equal to, this is your YNN minus I mean here YNN minus YNR, then YRR inverse YRN, right. So, here this is your what you call, this is your YNN, right, and this is YNR, this is your YRR inverse and this is YRN, right, and you multiply these 3 matrix, and whatever you will get, you subtract that from this matrix, right. Then you will get that your what you call that 2 into 2 matrix, that is your y is equal to minus J 3.435, then J 3.427, J 3.427 and minus J 3.44, right. That means this matrix also symmetric matrix, because y 1 2 is equal to y 2 1, this is your pre-fault, that is 2 into 2 bus reduction matrix, that is your reduced matrix, that is your 2 into 2. Now, power transmitted from bus 1 to bus 2. So, that is we know this equation from bus 1 to bus 2 after reduction, that P is equal to mod E 1 mod E 2 y 1 capital that mod capital Y 1 to sin delta. So, E 1 E 2 values are given initially, I told you, and y 1 2, that is your this one magnitude of this one, that is your, this is my y 1 2. So, magnitude of y 1 2 is equal to 3.427, right. So, here you will substitute, and initially I told you E 1 and E 2 values are given. So, that means during your pre-fault condition, that P is equal to 1.1 into 1.0 into 3.427 sin delta. So, this is actually 3.7697 sin delta, this is your pre-fault condition, right. Now, during fault condition, so since there is a 3-phase fault on bus 3, that means if we go back to the diagram, so that there is a 3-phase fault at this bus, there is a 3-phase fault, right. So, at this bus there is a 3-phase fault. So, in that case what will happen, the straightforward what we will do if 3 phase fault has occurred in that bus, right. So, what we will do that here, right. So, therefore, voltage of bus 3 will be 0 because 3 phase fault occurred at the bus, hence, the element corresponding to third row and third column will be absent, I mean they will be 0. That means, from this matrix, right, this matrix a fault has occurred at bus 3, right, at bus 3. That means, that third row, this third row and this third column, it should not be there. So, basically matrix will be reduced to that your 3 into 3, after that will reduce, that means all this element will be 0 during fault, right. So, I mean it will not be there, all will be 0 0 and here also all will be 0 0. So, this should be removed and this should be removed. So, this one will be there, this one will be there, this one and this one will be there. That means, matrix first will come down to 3 into 3, after that we will reduce it to 2 into 2, right. So, because fault has occurred at bus 3. So, your bus voltage 3, I mean voltage at bus 3 will be your 0, therefore, third row and third column will be eliminated from that matrix. If we do so, then this matrix will be 3 into 3 matrix will be during fault condition, that this is the matrix, right, because that row and column, third row and third column have been eliminated. So, in that case what will happen, that this is now my YNN, this is now YNR and this is YRN and this is YRR. So, it is a single element for this one, right, and we will bring it down to 2 into 2 matrix using the same relationship, that is YNN minus YNR, YRR inverse into YRN, right. So, in that case your if we do so, so YNN is equal to this much, I told you YNR will be this much, YRN will be this much and YRR is single element, right, and we know this formula, So, simply we will substitute and you just simplify, you substitute and simplify. If you do so, you will get that it is your minus j 8.330, this is 0 and this is minus j 5.83, right. That means, my y12 actually is equal to 0. That means, during fault condition it is P E1 E2 y12 sin delta. Ultimately, we are bringing it down, that your what you call that matrix reduction, that is number of machines, right, in terms of number of machines, the y bus matrix order. So, basically E1 E2 y12 sin delta all are magnitude, but y12 is 0. So, during fault that power is 0, power delivered will be 0. This is matching with that. By chance if you, this is a small example, by chance if does not it is only what you call a 2 machine case, right, and power we are only considering the power transfer from 1 to 2. So, U1 E2 y12 sin delta, right. So, this is 0. So, next one is that your post fault condition. We will not one thing I would like to tell, that we will not show you any swing equation or this simulation thing, because this I mean this course itself is a mathematical course full of mathematics, and if I show you swing equations and that coding and other thing, then it will consume lot of time and it is not a classroom exercise. So, whatever I have planned that things which can be solved in the classroom, right. So, next one is that post fault condition. Actually, during post fault condition, that if you come back to this, the condition for post fault is that, just let me go to the diagram, right, here for post fault condition. So, when fault is cleared, this line is out, right. So, this line and this line is there, these 3 lines are there, right. So, this line is out when fault is cleared, say. So, in that case, just hold on, let me go to that, right. So, in that case you simply construct, again it will be now 4 into 4 matrix, right. So, you can easily construct that y matrix, 4 into 4 y matrix. So, full matrix will be, now it will be only during fault condition third row and third column was eliminated, because fault occurred at bus 3, right. So, that bus voltage 3 is 0, but for post fault, when that line is removed, right, and this is that your network diagram, and if you construct the Y matrix, it will be like this, and you partition, right, you partition. So, this is your again, this is 2 into 2 matrix Y n n, this is your Y n r, this is Y r n, and this is your Y r r, right. So, and you use that same relationship, that your Y in general, Y is equal to Y n n minus Y r n, then Y r r inverse, then Y n r, right. You use the same relationship, then you will get, then it will be reduced to 2 into 2 matrix, right. So, this is Y n n, this is Y n r, and this is Y r n, and this is Y r r, right. You have to invert that Y r r, right. If you do so, so Y r r inverse will be this much, right. I mean, this is my Y r r, and that you invert 2 into 2 matrix, simply you can invert it, right. And then this is your Y, this is your Y n n, this is your that Y n n, that 2 into matrix, right. This is Y n r, this is your Y r r inverse, and this is your Y r n, right, and you multiply all and simplify. So, here this one, your what you call, I did not, this is an exercise for you, I did not compute, I did not give the answer, right, answer you will do it. Only thing is that Y 1 2 is equal to Y 2 1. So, Y 1 2 that I have written here, that I have written here, but you please find out what is Y 1 1 is equal to how much, and Y 2 2 is equal to how much. You multiply and subtract that from Y n n, right. And in this case, P will be U 1 E 2 Y 1 2 sin delta. This Y 1 2 only, you when you compute, you will get Y 1 2 2.4679, right. So, that means my P will be that E 1 1.1, E 2 1 point, and 2 point. One thing I have missed here, it is into sin delta, right, and P is equal to 2.71 power transfer, that from 1 to 2 7147 sin delta, right. So, thank you very much, we will be back again.